In this video, I'll be working through last year's grade 11 term 1 math investigation. This was the paper that was written by the KZN province, and it is based on nature of roots. So it says the aim of the investigation is to discover the characteristics of the x-intercepts or roots of a quadratic equation. So nature of roots, but it also centers around the quadratic formula. So this was written last year on the 20th of Feb. It was for a total of 50 marks and there was 1 hour allocated to completing this. So the quadratic formula, as you guys know, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Question 1 says, use the quadratic formula to determine the nature of roots of the quadratic equations below. So we have x squared minus 6x plus 9 is equal to 0. Now the first thing we do is we want to establish what a, b, and c is. Remember, a is in the format, or a is always the coefficient of x squared. So this equation is in the format ax squared plus bx plus c is equal to 0. So here our a value is positive 1, b is the coefficient of x, which is going to be negative 6, and c is the constant, which is positive 9. Now I'm going to substitute into this quadratic formula. We've got negative b plus or minus the square root of negative b all squared minus 4ac all over 2 times a, so 2 times 1. Now I need you guys to please simplify this before you get the values. Simplifying the first part, we've got negative times negative 6, which is positive 6. Then we have plus or minus, and you're going to put everything underneath the square root on your calculator. That should give you 0. Simplifying the denominator, 2 times 1 gives you 2. Now first working with the plus, if you put this on your calculator, you should get x is equal to 3. And then working with the negative, we get x is equal to 3 as well. So in this case, we notice that both of our x values are the same. Let's go on to 1.2. We're now working with x squared minus 4x plus 3. Let's establish a, b, and c. In this case, a is positive 1, b is negative 4, and c is positive 3. I'm now going to substitute into the quadratic formula. So we have minus b plus or minus the square root of b squared minus 4ac all over 2a, so 2 times 1. Let's simplify. Negative times negative 4 is going to give us positive 4, plus or minus, put everything underneath the square root onto your calculator. So we've got, this would be 16 minus 12, which is 4. So we have the square root of 4 and denominator is 2. Let's first work with the plus. So on your calculator, in your numerator, you're going to have 4 plus square root 4 over 2. That is going to give you positive 3. Next, let's work with the minus. So 4 minus square root 4 all over 2. That is going to give you positive 1. So unlike the first question, here we have 2 different x values. Now let's have a look at 1.3. We are given x squared minus 4x minus 3. So let's substitute. Negative b plus or minus the square root of b squared minus 4, a is 1, c is negative 3, all over 2a, so all over 2 times 1. Let's simplify. Negative times a negative is a positive 4 underneath the square root. So let's simplify underneath. We are going to get 28, and in the denominator, 2 times 1 is 2. Now you guys will notice that when you put this on your calculator, we get x is equal to 2 plus square root 7, which I'm going to change to a decimal. As a decimal rounded off to two decimal places, that is going to be 4.65. Or the next x value that you would get is 2 minus square root 7. And as a decimal, that is going to be negative 0.65. Let's go on to question 4. So I noticed that this watermark is blocking the question, but it is actually x squared minus 4x plus 7 is equal to 0. Okay, so let's substitute. We are going to have negative b plus or minus the square root of b squared minus 4ac, and in this case a is 1 and c is 7, all over 2a, 2 times 1. Now let's simplify. We've got positive 4 plus or minus underneath the square root. When you simplify here, you are going to end up with negative 12. And when you put this on your calculator, whether you use the plus or the minus, you are going to get a math error, which means that there is no solution to this answer. The reason why there's no solution is because in math, when we have a negative value under a square root, it is undefined, meaning that it is non-real. It does not exist. Let's go on to 1.5. Using the words given below, classify each of the roots from 1.1 to 1.4. So write down the roots and then describe them. So the words we are given is rational, irrational, equal, unequal, real, and non-real. So for 1.1, if we just scroll back up, the roots from 1.1 was x is equal to 3, x is equal to 3. Since it is the same value, there's no need to write it out twice. And the description, if we look at 3 is, and let's just go in order left to right here. 3 is a rational number. It can be written as a fraction. It's 3 over 1. So we're going to say that it is rational. We're going to say equal because we had two values that were the same. We had x is equal to 3 and x is equal to 3. So we're going to say equal. And we are also going to say real because these values do exist. Next, for 1.2, the values that we had, if we just scroll up, x is equal to 3 or x is equal to 1. Now, firstly, these values are rational. They are unequal because they're not the same. And they are real. Then 1.3. Now for 1.3, you're welcome to write 2 plus square root 7, 2 minus square root 7, or you can write down the decimals if you want. I'm just going to stick to the 2 plus square root 7 and 2 minus square root 7. Now firstly, you guys, these values are irrational. We are not getting a fraction in the form p over q. And when we convert them to decimals, they are non-terminating decimals. They do not end. So that makes them irrational. They are unequal because they are not the same values, but they are real. So we managed to get values, meaning that they do exist. And the last one, 1.4. We were not able to get any roots, but they ask you for the roots, okay? So since we don't have any values, you can actually write down the previous step where you had 4 plus or minus the square root of negative 12 all over 2. Or you can even write down not applicable, but I'm just going to put the last step that we had. And here, since there are no roots, they are neither rational nor irrational. They are neither equal nor unequal. And they are definitely non-real because they do not exist. Okay, we are ready to go on to the next part. It says, did you notice that the value under the square root sign determines the description you gave? This is called the discriminant, and that is true. If you guys have already covered nature of roots, you would be very familiar with the discriminant. It allows us to give the type or to determine the type of roots that we have. And what I mean by type is all of this that we have just done. We have examined the roots and we were able to say whether they are rational or irrational, equal or unequal, real or non-real. So it says, study the two tables above and then complete the following sentences. Now, before I go on, there's just something that I want to point out to you. If this is the first time that you are looking at this section, you may notice that b squared minus 4ac is a little familiar to you. It looks a little familiar. It looks as if we've seen it somewhere else before, and that is because we actually have. The discriminant comes from the quadratic formula. If you look carefully at what is underneath the square root, that is what the discriminant is, b squared minus 4ac. Now, coming back to this question, they say study the two tables above and then complete the following sentences. Before I refer to the two tables above, there is just a flow diagram that I want to go over with you. So this is really going to help you out. It's going to help you understand how the discriminant affects nature of roots. When we calculate the discriminant, there are one of two answers that we can get. We can either get a value that is less than 0, meaning that we get something negative, or we can get a value that is greater than or equal to 0. So 0 or a positive value. Now firstly, if the discriminant is less than 0, that means that the roots are non-real. So that was the case where we had the negative underneath the square root. Because remember, your discriminant is underneath the square root from your quadratic formula. In that case, there will be no roots. But we'll talk more about roots just now. And if it is greater than or equal to 0, the roots are real, meaning that they exist. We get values. From here, we can split up this greater than and equal to as equal to only or greater than only. For the discriminant being equal to 0, the roots are equal. There will be one root, so just one x value. But if the discriminant is greater than 0, then the roots are unequal. There will be two roots. Now we've seen all of that in the table that we calculated. We had an equation where we had only one root. We just had x is equal to 3. We had equations where we had two different roots. And we had an equation where there were no roots. So all of that can be determined by the discriminant. Now I've also made this table for you guys to study. So here it says if the discriminant is less than 0, the roots are non-real, so there are no roots. If the discriminant is equal to 0, the roots are real and equal. There would be one root. If the discriminant is greater than 0, the roots are real and unequal, so there are two roots. Now, going back to the question that we were on, they say, if the discriminant is less than 0, then the roots are. And from the previous flow diagram and table, we know that it's going to be non-real. Since they want us to use the table above, let's just go to that. We saw in this case where the discriminant was less than 0, we saw that there was no solution, meaning that the roots were non-real. So let's fill that in. The roots are non-real. If the discriminant is equal to 0, then the roots are. Let's go to the table above. Where we had the discriminant being equal to 0, let's find that question. So that was the very first one, 1.1. Look underneath the square root, that is your discriminant, and it is equal to 0. And what we notice here is that the roots are real, meaning they do exist, they are rational, and they are equal. We have the same value twice. So we're going to fill that in. The roots are real, they are rational, and they are equal. Next, it says if the discriminant is greater than 0 and a perfect square, then the roots are. So let's just go back up, and we are referring to 1.2. I want you guys to notice underneath the square root we have 4. So that discriminant is greater than 0 and a perfect square. So what does a perfect square mean? Square numbers are numbers that are made from other numbers being multiplied by themselves. For example, 4 is a square number because it's a product of 2 times 2, or 2 squared. So what we notice here is that we get 2 roots, so they are real, they are also unequal, and they are rational. And that we can also see from the answer for 1.2. Rational, unequal, and real. So let's fill that in. Rational, unequal, and real. So I noticed that the order from the previous one was a bit different, but that really doesn't matter as long as you have the correct descriptions, then it's fine. It says if the discriminant is greater than 0 and not a perfect square, then the roots are. So that actually leaves us now with 1.3, where we saw that they are irrational, they are unequal, and they are real. So let's fill that in. Irrational, unequal, and real. Okay, let's go on to question 2. So it says, without solving for x, discuss the nature of roots of the following equations. So in order for you to discuss the nature of roots, you need to know what the discriminant is. So for each of these equations, we will be calculating the discriminant, and based on our answer, we will state what the nature of roots are. Let's start off by calculating the discriminant. It is b squared minus 4ac. Here we've got b as positive 5, a is 2, and c is negative 3. Now we're going to simplify this, and it should give us 49. What we notice here is that the discriminant is greater than 0. Therefore, the roots are. When the discriminant is greater than 0, we know that the roots are real, they are rational, and they are unequal. Where are we getting this information from? If we scroll back up, it's the information that we had just filled in. Let's go on to 2.2. We need to calculate the discriminant, but before we do that, always make sure that the equation is in standard quadratic format. Standard quadratic format needs to have every term over on the left hand side and a 0 on the right. So I'm just going to prepare this equation first so that it is in the correct format. I'm going to take that negative 8 over to the left, and it becomes a positive 8. Now we can clearly see that a is 2, b is negative 7, and c is positive 8. Let us calculate the discriminant. Substituting in here, we have negative 7 all squared minus 4 times a is positive 2, c is positive 8, and when you calculate this, you get negative 15. This tells you that the discriminant is less than 0. And in that case, we know that if it's less than 0, the roots are non-real. So question 3.1.1 says, sketch the graph of f of x is equal to x squared minus 4 using point by point plotting. Show all intercepts and the turning point clearly. Point by point plotting. Okay, so we are going to take all of these values that we have, substitute them into the equation, and plot those points and then simply join them. Okay, so I'll start off with the values on the negative x-axis, and if I substitute -1, also another thing I want to point out is that it may become a bit tedious for you to use every x value, so as long as you are able to get the correct shape of the graph, that should be fine. Okay, instead of working with every x value, let's do this in a smart way. Let's calculate the x-intercepts and then the y-intercept, and that should make it much easier for us to plot. Also, seeing that this is only 3 marks. Okay, so I'm going to do this on the side. I'm going to start off by calculating the x-intercepts, and you guys know we make y 0. So we'll have 0 is equal to x squared minus 4. I'll take that -4 over to the left. We are then going to square root both sides. When you square root a value, it gets a plus or minus in front. So x is equal to plus or minus 2. So our 2x intercepts is going to be positive 2 and 0 and negative 2 and 0. If I plot those points, here it is. Next, let's calculate the y-intercept. And for the y-intercept, x is equal to 0. So in this equation, we're going to have 0 squared minus 4, so y is -4. So that point is 0 and -4. Let's find that on the y-axis and plot, and I'm just going to draw my graph through these points. So here it is. This is what your graph should look like, and you should get 1 mark for your turning point, which is also your y-intercept, as well as your x-intercepts with the correct shape of graph. Let us go on to 3.1.2. They say study the graph and then write down the values of the roots of f of x and discuss the nature of these roots. Firstly, you guys, roots are x-intercepts, and we clearly saw that the graph cut the x-axis at -2 and at +2. And if we discuss the nature of these roots, they are real because they do exist. They are rational because they can be written as a fraction, and they are unequal because they are not the same value. So remember, you guys, when you are giving the nature of the roots, there are 3 things that you're checking: whether it's real or non-real, whether it is rational or irrational, whether it is equal or unequal. Okay, let's go on. 3.2.1. Okay, so the writing's kind of covering here. It says sketch the graph of g of x is equal to, it's actually x squared minus 4x plus 4. Let me just write this here. G of x is equal to x squared minus 4x plus 4. So it says hint, complete the table below and then plot the values in the table on the set of axes given. So here we have a table, so we have to go with these values, which is fine. All we're going to do is take each x value, substitute into the equation. I'm just going to show you with the first value what it should look like. So we're going to have y is equal to -1 all squared. Remember, you are replacing x, so the square has to be outside the bracket. -4 times -1 plus 4. So you're going to put that on your calculator and you should get 9 as the y value. So you guys, let's pause the video. Let's take a minute to calculate these values, and when you have your table filled in, then you can press play. So here are my values. I've got, when x is 0, I have y as +4, x is 1, y as +1, x is 2, y as 0, and x is 4, and y is +4. Now all we have to do is plot these points onto the graph. So negative 1 and positive 9. Here is negative 1, and let us find positive 9. It is actually out of this graph because the highest y value we have is 7. So I'm just going to leave that point out. 0 and 4, that we can fill in. 1 and 1, that is here. 2 and 0, oh, sorry, 1 and 1 is here, my mistake. 2 and 0, that is our x-intercept. And then we've got 4 and 4, which is here. So they did miss a value. In case you're wondering why this looks odd, they actually missed out 3. But if they had 3, then it should have been 3 and 1. Okay, so I'm going to go ahead and join these points. So this is what the graph would look like. And the 3.2.2 underneath says, use the graph to determine the roots of g of x and discuss the nature of these roots. Now, roots is where the graph cuts the x-axis, and here we notice that it cuts the x-axis at one distinct point only, which is 2 and 0. So we're going to say x is equal to 2. Now, firstly, the roots are real because it does exist. It is rational because 2 can be written as a fraction, 2 over 1, and the roots are equal. They are equal because it is only one root. Let's go on to 3.2.3. Again, this graph is, the equation of the graph is covered, but it's fine, we can write it on the side. It is supposed to be h of x is equal to x squared minus 4x plus 2. So it's the same procedure where they want you to take all of these x values, substitute, and get your corresponding y values. I'm going to let you guys pause the video and try it out. These are the values that you should have. Now let's go ahead and plot these. Negative 1 and 7. So that is going to be here. 0 and 2, that is a y-intercept, it's cutting the y-axis. We've got 1 and negative 1, 2 and negative 2, 4 and positive 2, that is here. And then we have 5 and 7, which is beyond what's showing on the axis. So I'm going to go ahead and join these points. So this is more or less what the graph is going to look like. And the last thing I'm going to do is just label it h somewhere next to it. Okay, so all we did was joined those points. Now 3.2.4 says, does h of x have real roots? Explain your answer. So does it have real roots? Meaning, does it cut the x-axis? Okay, because that is what roots are. And yes, it does. It does cut the x-axis. So we're going to say yes. And the reason why it has roots is because the graph cuts the x-axis. Remember, if it didn't have roots, it would not touch the x-axis at all. Okay, now we can go on to question 4. It says, complete the following table summarizing the results from question 3. Now, according to what we've learned, if the discriminant is less than 0, notice this function, it doesn't touch the x-axis at all, meaning that the roots are non-real. Next, we've got the graph touching the x-axis once, and we have established that it only cuts the x-axis once when the discriminant is equal to 0. That is when the roots are real and equal. And the last part here, we've got the graph cutting the x-axis twice. The discriminant is greater than 0 and it is a rational number. That means that the roots are real, they exist. And in order for us to have two roots, it means that those roots are unequal. So they are two different values. that brings us to the end of this investigation. Hopefully this gives you guys more or less of an idea of what you can expect. Also remember to please continue revising. Please go over the table and the flow diagram that I've shown you for nature of roots. I wish you guys all the best.